place it correctly. If it's outside like that, that's bad. So it has to be inside the circle. You can rotate like this to have access. Here there's a code. These ones are still under incubation, so it means it's busy. But I think there's some other ones. Those ones are green, so it means we can take them out. So, because actually the incubation time is finished. See, there, it's all dark, and the watch is finished, and it's dark here, so that means it's finished.
Okay.
There's only 3 that still are left. So there's a few who are finished, so we can probably take them out.
Okay.
That's okay.
I can open the door during the work.
Huh?
I can open the door
Yeah.
during the work.
Yeah, you can. You have to press on up first, yeah. We have some, all those ones, the incubation time is finished, so I'll take them out. And I think that's it. So there's only those 3, and those 3 left, and the 3 we just put inside. So now when we close the door, it's going to turn around, and here there's a bar of sensor that will check if we put some new petri dish or not. And if we remove the petri dish too, it will detect it. So when the round is finished, so they should be. So there's this pop-up that comes out, and actually there's 10 columns A, B, C, D, E, F, G. So with the numbers 1 to 10. So I think I put them. So it will be in red. Here there's the 3 red ones. So actually the machine to start needs to have a name, a reference name, and then also you need to put in a parameter. And I can duplicate to make a copy. And actually this parameter is necessary to know which kind of light you want. So when you to start the cycle, you need to enter those data. So I validate. Okay, so it doesn't have any image because it didn't count it yet, but it's going to take those 3 and take an image. So here it goes under the camera and puts it back, and you can see the image appearing here. Yeah?
This is the first one.
This is the first one, so now it's the second one coming through. So you can see the light changes. Yeah, so you can see the 3 images. So it's going to take an image every 30 minutes.
This 30 minutes, I can change or
You can change to 30 minutes or 1 hour.
for 1 hour.
Yeah, that's it. So it's continuing the other ones too, the 3 other ones we put. Okay, so if we look at the software, here we have the different icons. So the analysis part is where we were. So this is all the petri dish that are inside the machine. And actually before there was the other petri dish, but I just took them out so they went off this sheet. And then I have a result approval and the archives. So when the analysis over, or if I take off the petri dish, all the petri dish will go in the result approval sheet tab. And when here I can modify the result still, I can check it and modify it. And when I approve the result, it will go in the archives, and in the archives you cannot change them anymore. So if I go in there, there's all the petri dish we checked. So maybe I can check them out and I'll check them all out. So that was the spiral ones. Nothing has grown. So I'll approve it. This one also, I think
It's clean, yes.
it's clean. Nothing grown, so I approve it too. So as I selected them all, it goes quite fast to approve that one too. But maybe if I have a doubt, I can add some colonies with my so that's a red one, so you don't see it very well, but I added 2 colonies there, and I can approve. So I can modify it still. So here I can still zoom in and and check what's going on. Yeah, maybe add a colony, and so on and so forth. Okay, those ones are the most interesting. But I think the counting was quite good. Actually, there's some, you can see there's a lot of condensation that appeared because we did the servicing, so I think overall the counting is not bad. So what's interesting is that you can see that the mark doesn't grow, so it's not counted. So the machine will only count what's growing. Yeah. So you can see there's some, I don't know, like the injection point, this hasn't been counted, and the dust neither. Maybe those ones should have been counted. Those 2. So actually here it's a petri dish that was already grown where we put them inside, so it's not a very good example. But still, probably I should add 2. If I want to be very accurate. Okay. And so on and so forth. You can add some comments and notes here too, and yeah, and that's it. So that's the approval part. And then if I come back to archives, so here I should put so there's all the things that we just checked in, so I can visualize it. So here I can check it. Actually, I'll have the graph. Maybe that one I should visualize. So here I have the graph. Also, I have the temperature. So that's interesting for auditors because usually for accreditation they ask you what was the temperature of incubation, etc. So here you can have the data of every petri dish with the incubation time and date. So that's interesting. So you can prove that you've incubated minimum 24 hours, and you can prove the temperature was also at 37 degrees all the time. So that's quite interesting, I think. So here you can see the 2 colonies I added. You can check them up, but you cannot modify it. So that's how it works, basically. But then after, also you have an export button, and you can export a lot of different types of data. Mainly the PDF format, CSV, which is Excel, and a video also you can export, and also you can export the images. So for every type of export, you have a choice of making it small, detailed, or colony. So it's small, medium, or big. So depending of how much detail you want.
So if I have 2 different type of bacteria, one need temperature 36 degrees for growing, and the other need 45 degrees for growing. If I put together, what is the temperature?
So actually this one, this machine is only one temperature.
One temperature.
So you set the temperature. Here, for example, I set it at 37 degrees. But you set it, you can change the temperature, of course, but there's only one temperature. You can have different petri dishes with different type of setting and different type of batch at the same time, but with a mono temperature. So I can show you how to change the temperature.
Okay, no problem.
For example, here I'll set it to 35.
But this is the total temperature for the incubator.
Yeah, exactly. I'll add it.
ده معناه يا باشمهندس امير ان انت لو هتشتغل على 37 يبقى كل التستات اللي جوه 37
على 37
هخلصها وبعدين اعمل التستات اللي على 45.
ما يعني ما يتحطوش مع
لا،
بعض.
ما ينفعش
مش هيشتغلوا معاك. I told him Manuel that that's mean I'll
To 35, so the temperature is going down, and you can see that the fans, it's cooling down inside, so they're making a little bit more noise until they reach the right temperature. You can also set program temperature change, for example the next day, so you just need to set in the time and date you want to change it. Also I can show you the different kind of parameters. So actually when we added a petri dish, the software asks us for a setting. So there's different type of setting or parameters you can create, and it depends on your type of analysis you're doing.
So if I wanted to count two different types of bacteria, how I can identify the software?
Okay. What kind of bacteria would you be looking for?
Escherichia coli pseudomonas.
Okay.
In the same sample,
same
in the same
percentage.
petri dish.
So do they look the same? The colonies?
color. Just talking about color. Yeah.
Color differentiation.
Yes.
Huh?
Color different.
So if the color is different, you can set a different color. Okay. So we'll add a parameter. You can call it E. coli and Pseudomonas, for example.
Yeah, okay.
And then in the color, you'll add a color, and you put the name of the color, and then you have to select a color. So here you click there. Either you choose a color like this, okay? So that works not very well. The best is to load
What color?
a petri dish you already did. So that takes a little bit more time, but you need a plate on which you have grown Pseudomonas and E. coli on the incubator, and do a normal counting without color counting. And when you have this petri dish, you validate it, you finish the incubation, and then here you can load this petri dish and a reference. So I have to find the name of the petri dish and find it, and then I can click on the colonies that have been counted, so I can take the exact color. See? So that would be the best way to do the color counting and differentiation.
You have a program for Escherichia coli and program. I see it.
There's one for E. coli, because there's a common agar we use in Europe, which is called TBX, which colors the E. coli in blue.
Yeah.
So we did a preset. So I think if I use TBX color, I think it should have the blue. I don't know why not, but yeah. On this setting it will count blue, but you can count to four colors. I mean,
also we same the use we use the same
Media.
TBX, yeah, okay, yeah. So that works fine.
so yes, give you colonies with blue colors.
Yeah, exactly. The only thing is that when you're looking for color, the normal settings, for example this, the lighting comes from the bottom, the white background, and the colors will be black because we're looking at the shade of the colonies. If you want to differentiate the colonies with color, you need to be able to see the colors of the colonies, and the light from below is not the best. So you have to add light from above, so that there's a reflection, and the camera can see the color of the colonies. So you can see, for example, in TBX, the light will come from the top too, from above, from the bottom, and also from above. Okay, so that's quite important if you want to do some chromogenic agar. Yeah. But it kind of makes sense, you know. If you want to look at the color of something, you have to put some light so there's a reflection of the color. So that works fine, but the setting takes a little bit of time, and you need to do a first incubation and then retrieve the color on an image to be able to do the count. So it takes a bit of time. Yeah. So maybe I can show you the different settings there is. Okay. So there's the manual plating like we did. Also there's the spiral method. So here you can configure. So it depends the kind of plater you have. So we pre-memorized all the Interscience platers. For example, the dilute. We select the dilute, the kind of plating, exponential, circle, and also the volume deposited. Yeah. There's also an interesting settings you can use. Here we use the standard grid, so we're going to count on this side and on that side. If you select all sectors here, yeah, it will count on a full circle. So it seems a bit strange, but it is as if we did two counting. Actually, we do 1/4 and 1/4, and then we do 1/4 and 1/4. So we add them up, and it makes a full circle. And with this, the accuracy will be higher actually, because we count more colonies. We don't count 20, 20. We count 20, 20, and 20 and 20. So like 80 total minimum colonies. So it makes it more accurate. It's as if you did a double counting with turning the plates. You see? So actually, this is a best setting. Yeah, we don't use it with when you count it with the hand because it takes more time. It takes double the time, but the machine it doesn't care if it counts double the time. So I would suggest to use this setting. It's better for the spiral. Actually.
Okay.
For the spiral. Okay. And also you can use filtration membranes.
Yeah.
Filtration membranes is a bit difficult because most of the time the agar is transparent and we use light from below. And the colonies will be dark and opaque, so we have quite a good contrast, you see? So we can see the shade of the colony. Even if the colonies are white, usually we see them dark. Because the agar is transparent. If you use filtration membranes are white and opaque. Usually you use a cellulose membrane, and if you put light cellulose membrane, with the filtration system. And so if you put light from below, there's not enough contrast. Right? So the contrast is quite low. So sometimes the counting, the accuracy is not so good.
In this situation, it will light from up.
So you can light from above, but if you put some light from above, the problem is that the colonies are white usually, on white membranes, and there's no contrast. So one thing that works better is to use dark membranes with colonies with a light from the top, like filtration membrane. Also, what works is polycarbonate membranes. They're very thin and transparent, so if you put light from below, the colonies will appear dark.
Cellulose membrane is not preferable.
No, one thing that works very well with cellulose membrane is if you use like selective media. For example, if you use selective media for E. coli or coliform, there's some ink that goes in the colony when a colony grows. So the colony will appear blue or red. So I think in water filtration, sometimes you count all the colonies, but sometimes you also count coliform, E. coli, and you use selective media. So there's a dark blue colony on a white cellulose membrane. The contrast will be good, so the counting will be very good too. But if the colonies are white and you use white cellulose membrane, there's not enough contrast. So I just wanted to warn you about this membrane filtration.
Yeah, this is a good point.
In some cases it works, and in some cases it doesn't work so well. So please try to do some tests. If ever you have some problems, please ask us. But the best is to use agar, selective agar, which will tint the colonies. That works very well.
We usually use
coliform, dark, okay, for water. So the colonies will appear dark pink. Something like that.
Dark pink,
Dark pink red, yeah. So this should work fine. Yeah.
But thank you for this point.
Yeah.
Thank
So
you very
it's
much.
yeah. So it's a bit difficult to be honest. Sometimes. If you use filtration membrane, size of petri dish. I think it will adapt the diameter to read only on 55 millimeter membrane. Maybe I'm not sure. Maybe you have to select 60 or 55. I'm not sure.
It's not different.
It's just the reading area will make it smaller.
We add the filter.
Yeah, you add the filter on a 90 millimeter petri dish. Yeah. But the machine has to read on a smaller area. So, but I don't know. Maybe you need to keep 90 millimeter.
Oh,
What
okay.
about the holder? Will you minimize or what?
The holder.
Yeah. If I use another size.
If you go another size, actually the gripper adapts itself to the different size of petri dish as long as it's around 90 millimeters. So actually the gripper, you can put the petri dish on right side up or upside down, and the gripper, when it feels the petri dish, it will stop. There's a force sensor, okay? So it can hold it from like this, from the bottom or from the top. But if your petri dish is very small, we have some special adapters. I'll find it for you. So we had a few. I don't know, they're not here. I don't know where we put them. In there.
Yes.
Then after, if you wanna, okay, I'll go back to manual method. There's different type of units you can input. If you're doing food samples, usually you will look for CFUs per gram. But if you're doing water, maybe it's an ml. And if you're doing surface swabs, it will be a surface. So decimeter square. And if it's air, from an air sampler, it could be in meter cube. See? So there's different units you can select. So the result will be in the unit you want. And if you don't know and you don't care, you can just use a CFU. And that's it. So each time you select a different thing, it will indicate the right parameter to put in.
طب فين المليان؟ كل المليان نفس دي.
So here it says 25.
زيرو غير واحدة وتيجي واحدة ازاي؟ إذا كان الدكتور عبد الرحمن عنده بنغير عنده واحدة.
It's the filtration and
Sorry?
and here.
Yeah?
لا ما بتجيش
It says filtered volume.
الناس
Yeah.
بتتكلم خالص.
So I don't know, maybe
100
100 milliliters.
maybe 1
1 liter.
Ah.
Yeah, probably. Yeah. Exactly.
هم فين من يومها يا أنس؟
I think you have is the only choice in filtration membrane. And spiral. Spiral is only ground an ml because you don't do air on spiral. And manual, you have the more choice. So yeah, it's not too. No? Manual. Yeah.
That's hard.
I don't know.
Yeah.
Maybe you can. We have to scroll. Yeah.
Yeah.
I don't know. It looks different. Yeah, the same. Okay.
Okay, enjoyable.
احنا متابع يعني.
It's okay. And so I show you the color. Okay. Okay. Also, you can add some colors. For example, E. coli and I don't know, Salmonella. You can also edit maximum concentration per bacteria per color. Okay. Also, you can exclude a color if ever there's some colonies that are counted as E. coli, but the color is a bit close, you can exclude this color. And you can also set a sensitivity to color. But to be really honest, there's not so many customers who are using chromogenic media. Not so many. Usually chromogenic media is for detection. For example, Salmonella or Listeria, you use chromogenic media, but you're only allowed, you're not allowed to have any in food usually, so you don't need to count it. So when it's detected, that means the sample is bad. So you don't really need to count. You don't really need to check the color because on selected media, everything, sample is bad anyway. So yeah. Usually use a colony counter for quality indicators, coliforms, total count, where you have something to count. For pathogens, well, it's interesting because you detect earlier, but you don't need to count actually. And then there's all the thresholds. So here you can input a maximum authorized concentration. For example, in beef sample, you're allowed 3,000 coliforms. So this you can edit here to have a limit. And also you can fix a limit on the number of CFUs you can count on a plate. For example, if you do several dilutions, maybe the first one there's too many colonies, there's 3,000, so you shouldn't count it and take it into account in the calculation. So you can set a limit to maybe maximum 300. And also you need a minimum, because if you have only one bacteria, one colony is not enough to have a very accurate count. So usually the limit is between 30 to 300. So if you fix a limit like that, and you have several dilutions, maybe the first one is 3,000, the second dilution is 300, and the third one is 20. It will only take the 300 one, which is in between. 3,000 is too much, 20 is not enough, so it will take the calculation of only the one which are in the range to be counted.
If we use the filtration,
Yeah.
filtration, water, the limits between 10 and 100.
Oh yeah.
That's
Okay. On the membrane.
Uh,
Oh yeah, I didn't know. Okay, so put 10 and 100. Okay. So it depends a little bit on the application, but usually the minimum is around 10 to 15, 20, 30, and maximum is about around a few hundred.
yeah.
Yeah. Actually, the minimum is that you don't have enough statistics, enough elements to have a good statistic calculation. So that would be the minimum. For example, if you have only 2 colonies, if you add 1, it will be 50% variation, so that's too much. And the maximum limit usually is that when you have too many colonies, they fight, and they're not all going to grow, so the count is not going to be accurate. So there's only a range where it's going to be accurate. Okay, here you can put the incubation time in hours.
If we skip this,
You don't need to put,
okay.
if you don't put any thresholds, there's going to be a counting, but you don't have a warning when it goes above a certain limit. But for research purpose, you just want to count, so you don't need to put this, huh?
Okay.
Yeah. But I mean, it's your choice. Yeah.
If I applying sensitivity test,
Sensitivity tests. What is that?
that's I put something like antibiotic
Yeah.
in the plate and put pathogen
Yeah.
and see the clear zone and
Oh yeah. Inhibition zone we call it.
Yeah.
So he's gonna make a circle around. Yeah. This doesn't work.
we work with the scan 500.
Yeah.
Just saying it.
Yeah.
Short for this.
عشان تحسب كمان الاريا نفسها قد ايه.
Yeah, we haven't developed the
yeah,
application.
yeah.
Because we haven't developed the application. So total incubation time, I think we start counting up to from 4 hours, because before 4 hours, nothing grows. The fastest bacteria is E. coli, and I think it kind of appears from 6 hours. And the maximum is like 10 days, I think, incubation time. Usually after 10 days, the agar is completely dry, so nothing grows. So. But I know in pharma industry, sometimes they do 7 days. It's quite common.
For what?
Pharma, application, because they in the clean rooms they want to grow everything, even the colonies that are growing very slowly.
Yes.
So they wait until 7 days to be really sure. Maybe there's a small colony that
Istanbul-
goes after 6 days, probably.
Yeah,
Yes.
So they want to be safe.
yeah.
Yeah.
Even in,
Yeah.
I think all products, even in creams and shampoos.
Oh yeah.
like
They
this.
do it very long.
Yeah, do it.
Yeah, very long.
كمان زي in field of food they take a final product and incubate for 15 days, and after that we have a sample.
Oh
and
yeah,
test.
check it.
No,
Yeah,
check.
yes. Yeah. Okay, you mean, for example, for the shelf life of food, they do some tests
Mhm.
to see what will be the shelf life of the
Yeah,
food, for example.
yeah.
Yeah, true. And I know in cosmetics industry they do something which is called the challenge test. So it's a test where in cosmetics they want to know what dose of preservative they need to put in the cream. And to be able to determine this dose, they want to put the minimum, but they need to put enough so that if ever the cream, there's a lot of bacteria growing, you're putting on your face, it's going to be pretty bad. So they need a minimum dose. So what they do is that they take some cream with different dose of preservative, and they inseminate bacteria, and they test it after 1 day, 7 days, 30 days, and they see how the growth, if it grows or if it goes down.
Yeah.
So
I was doing this in
that's quite
my
common.
company in Egypt.
Oh yeah, they used to do, okay. Because in France there's a lot of cosmetic makers. There's L'Oreal, but you know all the L'Oreal is the L'Oreal is a world leader.
There is Uriage.
Oh yeah, Uriage. I mean Chanel, Dior, Biotherm, yeah, there's so many cosmetics companies in France. So they're using this kind of machine to do the R&D and the challenge test too. So it's quite used in cosmetics. We have to do a trial at Chanel. Haven't tried yet, but they're gonna. I think Chanel is gonna try one of those machines. So I hope they buy it. It's a good famous name. Okay, and here the recurrence, you can select 30 minutes or 1 hour. So actually we have 3 models: the 100, this one, the 200, and the 300. And the 100 and 200 they can do half an hour and 1 hour, but the 300 we can only do 1 hour because we don't have the time to pass all the petri dish in half an hour.
Right, yes.
So you would think the quickest is the better. So we talked about it a little bit before, but actually the shorter you do, the less growth you see between images. So the less counting is good actually. So actually 1 hour I think is the best. So 1 hour is the best because it will count better actually, because you see more growth in between images, and also the data is a bit smaller. So if you do a lot of testing, every half an hour maybe is big. So
if I get result after 8 hours, it will take 8 pictures.
yeah,
It's reasonable.
it's reasonable. Yeah. So I mean it's your choice. Where if you don't do so much testing, maybe half an hour is good. Yeah, you choose.
Maybe half an hour will be good with the research.
Yeah, for sure, for research. Yeah. Because you want to have more data. Yeah.
Routine work.
Routine work 1 hour is enough. Yeah. And also you think maybe if it's half an hour, the detection time can be a little. You can have half an hour shorter maybe. Probably. Yeah.
Sometimes the bacteria is fast to grow.
Yeah. So maybe 30 minutes is good.
20 minutes to duplicate it.
Yeah, exactly. Yeah.
So it's 30 minutes is very
It's good. Yeah. That's true. Actually, in food, the incubation time is not so long. Usually it's 1, 2, 3 days.
3 days maximum.
Yeah, maximum. Yeah.
Sometimes no.
Well,
Yes,
for
a
mold,
mold.
instant mold can be 5 days, but it's not the
5 to 7
majority.
days.
Yes, come on.
But I compare it to the pharma industry where it's minimum 5 to 7 days. So they would choose 1 hour directly. I mean, never they would do half an hour. It's too much data. But if incubation for food application, I think half an hour is good. So anyway, you choose. So Yeah, so I think we saw everything.
Yeah,